Today I'm gonna talk about the derivative of composite function chain rule. I'm gonna focus on the exponential function. Now let's take a look at the following four formulas. The first one is general exponential function. So the derivative of a to the power fx equals ln a times a to the power fx times the derivative of fx. And the second formula actually is the special case of the formula 1. We change the base a to the e. So the derivative of e to the power fx equals e to the power fx times the derivative of fx. The third one is the power rule. And we also have a special case that is derivative of x equals 1. The fourth one is the constant rule. The derivative of a constant equals 0. And the last one is the constant multiple rule. We can pull the constant out of derivative. Now let's take a look at the first example. As we can see, for the first example, we know that a is 2. Okay, so what is the fx? Fx is x cubed. Okay, then we can apply the first formula. We're gonna have ln a ln 2 times a to the power fx, that is 2 to the power x cubed, times derivative of fx, that is derivative of x cubed. And for this derivative, we can apply the power rule. Here the n equals 3, so we have ln 2 times 2 to the power x cubed times 3 times x to the power n minus 1, 3 minus 1. Then we can simplify it. We put a 3 in front of ln 2. We have 3 ln 2 times 2 to the power x cubed times x squared. Okay, now let's take a look at the second example. For the second example, we know the base a equals 4. Okay, so what is fx? Fx is c over x. Okay, c over x. Now we can write down the formula. So ln a is ln 4 times a to the power fx. So a is 4 to the power fx, that is c over x, times the derivative of fx. Okay, for this derivative, we have c over x. Okay, and we're gonna transform it. How to transform it? We're gonna follow the formula here. So we have, if we have 1 over x to the power n, that can be x to the power negative n. So for this case, we can have ln 4 times 4 to the power c over x times c times 2 times x to the power negative 1. Okay, and here c times x to the power negative 1, we can apply the constant multiple rule. We can pull the c out of the derivative. So we have ln 4 times 4 to the power c over x, c times the derivative of x to the power negative 1. Now we can apply the power rule. Okay, n is negative 1. So we have ln 4 times 4 to the power c over x times c. Here's a negative 1, x to the power negative 1 minus 1. Okay, we can move the negative and c in front of ln 4. So we have a negative c ln 4 times 4 to the power c over x times x to the power negative 2. Now let's take a look the third example. For the third example, we can see the base is e, so we can follow the second formula. We can find the fx equals x squared minus x. Okay, now we can follow the formula. That should be e to the power fx, e to the power x squared minus x times the derivative of fx, x squared minus x. Okay, and for this derivative, that is difference rule. The derivative of the difference of two functions, so that means we're gonna do the derivative for each function. So we have e to the power x squared minus x, and we do the derivative for each function. Okay, and for the first derivative, we can apply the power rule, and for the second one, we can directly use the derivative of x equals 1. Okay, so we can simplify it. E to the power x squared minus x. Here should be a power rule, 2x to the power 2 minus 1 minus derivative of x should be 1. Okay, and we're gonna get e to the power x squared minus x, and here should be a 2x minus 1. Now let's take a look the last example. For the last example, we can tell what is fx. That is square root of x. Okay, again we can follow the formula 2, and we can write it as e to the power fx square root of x times the derivative of fx, derivative of square root of x here. Now for this guy, we can do the transformation because we know that it is a formula nth root of x equals x to the power 1 over n. Okay, so here is the square root of x. That means x to the power 1/2. Okay, so we have e to the power square root of x times x to the power 1/2. Now for this derivative, we can apply the power rule. We have e to the power square root of x 1/2 x to the power 1/2 minus 1, and now we can simplify it. 1/2 x to the power negative 1/2, okay, times e to the power square root of x. Okay, that's it.